I'm now going to review the independent practice problems for compositions that you worked on. Let's look at the first problem. This problem says figure BCDE was transformed using the composition. If point B on the pre-image lies at, what are the coordinates of the image that contains vertex B prime on the final image? So, we have been given our original coordinates of B on the pre-image. We have also been given our different transformations that compose our composition. So what we want to do is go ahead and identify these different mapping rules. The easiest way for us to identify these mapping rules is to go back and reference our rigid transformations foldable. Okay, so we know that we have two different types of transformations that create this composition. We have a transformation which maps to and we also have what looks like a reflection across the x-axis, and we know that reflections across the x-axis tell us to take our original coordinates and to go ahead and switch the x and y coordinates and then negate the y. Well, we know that we read this composition from rightmost to leftmost. So first we want to do the transformation. So what we're going to do, I'll use a different color just so we can see this a little better, is complete the transformation rule. So the transformation tells us to add 2 to x and to add 2 to y. So we get 5 and 6. And then our next transformation tells us to keep the x and y coordinates where they are, but to go ahead and negate the y. And so we have found our resulting coordinates of B after that composition of transformations, which gives us the answer choice B. Let's look at our next problem. This problem says, what is the final transformation in the sequence of transformations mapping pre-image V, W, X, Y, and Z to final image V prime, W prime, X prime, Y prime, and Z prime? So we're looking for the final transformation. So what we want to do is identify our pre-image, our image after our first transformation, and then our image after our final transformation. And so what we're being asked to identify is what is the final transformation. So our final transformation takes place between our image 1 and our image 2. So we want to identify what transformation did we apply to image 1 to result in this last image. Well, it looks like we had a type of rotation, specifically a rotation about point Z prime. So we had a rotation about point Z prime. And now we want to identify what the degree of that rotation is. Well, it looks like we have had a rotation about Z prime 180 degrees. So we want to look for the answer choice that tells us that we have a rotation about Z prime 180 degrees, and that is answer choice D. Let's look at the next problem. This problem asks, which figure represents the final image after the following composition is applied to rectangle LMNP, which is our pre-image. So here we have our pre-image. We want to identify the figure that represents the final image, so image 2, after this composition. Well, remember we read this composition from right to left. So first we complete the translation, which tells us that we add 3 to x and add 1 to y. And then we complete the reflection across the y-axis, which tells us to go ahead and keep x and y the same, but negate the x. So the first thing we want to do is identify a point on the pre-image. So let's do P. And here we have P located at what looks like -3 and 1. So P is located at -3 and 1. Well, let's complete the first transformation. So we would add 3, which gives us 0, add 1, which gives us 2, and then we would complete the next transformation, which tells us to keep the x and y coordinates where they are, but to go ahead and negate the x. So negating a 0 just keeps it 0. And so we are looking for P at 0 and 2. Well, let's locate 0 and 2. And as we can see, only one figure has a specific point at 0 and 2. And that is figure number 4. And so D is our answer choice. Okay. We can also double check this by going ahead and taking vertex P, completing the transformation. So we have 3 units to the right. 1, 2, 3. 1 unit up. And then a reflection of the P. And so we get figure 4. Let's go to the next problem. This problem says, Kayla applied this composition of transformations to a triangle, ABC. Which mistakes does she make? Check all that apply. Well, we want to identify that pre-image. And then we want to write down these transformations in order. So first we have a translation, 0 and 3. And then we have a reflection across line M. Okay, so we want to see if this diagram matches that. So first, what we should do is complete a transformation. Well, here's image 1, and here's image 2. Again, we know this is our image 1 after the first transformation because it contains 1 prime notation, while this one has 2. And so what we needed to do first was actually do the translation first, but it looks like we went ahead and did the reflection first, which is her first mistake. So we want to see these different answer choices. And it looks like this statement acknowledges that she applied the reflection to the triangle first, which was her first mistake, right? Because we had to follow the order and actually do the translation first. So let's look for another mistake. Would also look like she attempted to do the translation next, but she did not keep the image 1 and image 2 congruent. Instead, she increased the size of image 2, which is not a characteristic of a translation. Remember that rotations, reflections, and translations are a type of rigid transformation. This means the size, shape, angle, measure, length, etc. does not change. So her next mistake was that she changed the size of the triangle, instead of just applying the translation. So we want to look for the statement that go ahead and explains this, and that is this one. She changed the size of the triangle instead of just applying a transformation. These are the only two mistakes that I can identify, but let's read the other statements just to make sure. She applied the rotation to the triangle first. Well, it doesn't look like she applied any rotation, so that is not an answer choice. She translated the triangle down instead of just applying a reflection. What doesn't look like in any instance, she went ahead and translated an image down. She applied a rotation instead of a reflection. Well, again, it doesn't look like she applied a rotation. So those are our only two answer choices. Let's look at the next problem. This problem states, which rule describes the composition of transformation that maps the pre-image DEF to our resulting image, image 1, D prime, E prime, F prime. So what we want to do is, like always, identify the pre-image, the image after the first rotation, or the image after the first transformation, and then the image after the second transformation. So what we want to do is identify how to get from this pre-image to our image 1 first, because that will represent our first transformation. Well, it looks like what we did was apply a rotation about the origin 90 degrees. So that is our first transformation. Well, let us know and remember that we create compositions where our second transformation appears first, and then our first transformation appears next. Remember that we read compositions of transformations from right to left. So what we want is for this transformation to be placed after the compose symbol. And the only instances in which that happens is B and C. So we can go ahead and cross out A and D. Let's look at the next thing. We want to identify how we get from image 1 to image 2. Well, here we have two options. We have a translation by -5 degrees or a translation by 5 degrees. Well, -5 here tells us that we have a translation to the left. So we move left horizontally 5 degrees. Well, let's see. Let's look at this E prime. And let's move it left 5 degrees. 1, 2, 3, 4, 5. And it does in fact map to our resulting E prime on the image 1. Well, let's just double check the next statement to make sure that one has an inaccuracy. Here we have a translation of +5, so 5 units to the left. Well, again, we'll identify E prime and move 5 units to the left. 1, 2, 3, 4, 5. Well, it doesn't look like our transformation took place this way because this does not map to our image 1. And therefore, we know that B is our correct answer. First, we complete a rotation about the origin 90 degrees, and then we complete a translation 5 units to the left. Let's look at the next problem. This problem asks us to analyze a diagram. What is the composition of transformations that was applied to our pre-image W, X, Y, Z to W prime, X prime, Y prime, and Z prime? So again, let's identify our pre-image, image 1, and image 2. Well, we know that our first transformation will tell us what happens between our pre-image and our image 1. Well, it looks like between our pre-image and our pre-image and image 1, we had a type of rotation. This specifically a rotation about point A. And it looks like we had a rotation about point A 180 degrees. Now, our second transformation will tell us what happens between image 1 and image 2. Well, it looks like what we had here was a reflection across this line, specifically a reflection across line M. And so therefore, we have identified our first transformation and our second transformation. If we wanted to create a composition of transformations, we would write this as our first transformation as the rightmost transformation, and then our second transformation as the leftmost transformation. Let's look at the next problem. This problem asks, which rule describes the compositions of transformations? Let us look at this next problem. This problem asks, which rule describes the composition of transformations that maps rectangle PQRS to P prime, Q prime, R prime, and S prime? Well, the first thing we should do is identify our pre-image, and then go ahead and identify our resulting image. The easiest way to go about answering this question is to identify a specific vertex on the pre-image. So here we have S, which is located at -3 and -1. And then identify where it is mapped to after the composition. So the composition has taken place on the coordinate grid, but we want to identify what the rule for that composition is. So we'll look for S prime, which is located at 1 and 5. Or -1 and 5 rather, sorry. And so what we want to do is go ahead and identify which of these composition rules will allow us to get from our S vertex at -3 and 1 and our S prime vertex at -1 and 5. The easiest way to go about this problem is to apply each of these mapping rules to this original coordinate. S is at -3 and -1. And then to see which of these rules allows us to get to our resulting coordinate. S prime is at -1 and 5. So let's look at our first option. It says here that we have a translation 2 units up, so we'll take -1 and add 2, which gives us 1. And then we will go ahead and complete the rotation 270 degrees, which tells us to switch the X and Y and then negate the Y. And so as we can see, our resulting coordinate after that composition of transformations does not match the coordinates of the image in our grid, and so that we know that A is not our answer. So we'll try the next one. First, we start with a translation 2 units to the right. So S, -3 plus 2, sorry. Then we'll do the rotation 180 degrees, which tells us to keep the X and Y coordinates where they are, but to negate them. And again, we can see our resulting coordinate does not match the coordinate we are looking for, and so that is not our answer choice. So we'll try the next one. Here we have first a rotation 270 degrees, which tells us to switch the X and Y coordinates, and then to go ahead and negate the X. And then we have a rotation up 2 degrees, so we have S, -1, 3 plus 2 gives us 5. And so we have finally found our compositions of transformation rule that allows us to get to our resulting coordinate, S prime, in our image 2. Okay, let's go to the next problem. This problem states the sequence of transformations, and then we have been given a compositions of transformations, is applied to the pre-image x, y, and z to produce our image x prime, y prime, and z prime. If the coordinates of our image vertex y prime are 3 and 0, what are the coordinates of our pre-image vertex y? Well, so what we want to do is identify what our rules for this composition of transformations were. So first we did a rotation about the x-axis, which tells us to take our original coordinates, keep them where they are, but to negate the y. And then we had a rotation 90 degrees, which tells us to take our original x and y coordinates and to switch the x and y and negate the y. And we have completed this transformation theoretically from right to left. And so, in doing so, we arrived at this coordinate. Well, what we want to do is work backwards in order to find our original coordinate. So we know that at the end we arrived at y prime equals 3 and 0. So the first thing we'll do is go back on the rotation. So we will go ahead and switch back the x and y. And then reverse the negation. Right? And we can double check that by saying, well, if we had, this is our original coordinates and we applied that rotation rule, well, then we would switch the x and y and then negate the y. And so we did, in fact, go ahead and reverse that. And so now that we've reversed that, we'll go ahead and reverse the reflection, which tells us to keep the x and y where they are, but to negate the y. So we'll reverse that negation. And again, we can go ahead and check that by taking our coordinates, applying that reflection again. And we can see that we did that correctly. And so in the end, we have arrived at the coordinates of our pre-image y vertex, which is 0 and 3. Let us look at our next and final problem. This problem says to analyze the pre-image of A, B, C, D. What are the vertices of the final image if we have this composition of transformation is applied to that figure A, B, C, D? What we want to do is identify the coordinates of A, B, C, D. So A is located at 2 and 4. B is located at 4 and 4. C is located at 3 and 2. And D is located at 1 and 2. And so we just want to double check that. 2 and 4, 4 and 4, 1 and 2, and 3 and 2. Okay, so there we have our original coordinates of our pre-image. And so once we have those original coordinates, we want to go ahead and identify what our first transformation will be. Well, remember, we'll read this from right to left. So the first one will be the reflection of y equals x, which tells us to go ahead and switch the x and y coordinates. So what we want to do is switch the x and y coordinates of each of these. Okay. So I'm going to move this just so we have some more space. And then we'll apply our next transformation, which tells us to take the original coordinates, subtract 1 from x, and to also subtract 2 from y. So that's our translation, so we will do that. Let me move this down just so I have some more space again. Oops. So we can see this just a little more clearly. I will move it right here. And so we want to do that. Well, if we subtract 1 from 4, we get 3. If we subtract 2 from 2, we get 0. If we subtract 1 from 4, we get 3. If we subtract 2 from 4, we get 2. If we subtract 1 from 2, we get 1. If we subtract 2 from 3, we get 1. If we subtract 1 from 2, we get 1. And if we subtract 2 from 1, we get -1. So, as you can see here, we did our first transformation. Let me move this back because I can see that it is being blocked. Or I can move this actually. So the first thing we did was apply this mapping rule, which tells us to switch the x and y coordinates. And then after we did that, we completed the next mapping rule, which told us to subtract 1 from y and subtract 1 from x and subtract 2 from y. And as a result, we found our resulting coordinates of our image 2 after that composition of transformations. I hope this was helpful, and I hope that this helps you succeed on our Unit 2 exam. If you have any questions or concerns, please feel free to reach out so that I can help you.